Good morning, ladies and gentlemen. So, welcome to the panel discussion organized with the theme of the future sustainable tech. The sustainability is one of the major topic we have to discuss always with the UN sustainability goals, and in 2015 17 sustainability goals established by the UN for the whole planet. And all the countries, disregarding their differences, they have to align with the sustainability goals, 17 goals. I am not going to talk on each and every goal which are available under the sustainability goals set up by the UN. And today's our discussion here we are planning on 4 thematic areas within the technology. And we have 4 eminent scientists and the academics here to talk on these future technologies which are leveraging towards these sustainability goals. And if I summarize the sustainability goals with a few sentences, it's about the peace and prosperity for the human and planet. And in that sense, when you look at the sustainability goals, the peace, the first word, is under challenge in the global arena. If you consider about the technology usage of that particular type of the peace or the war in the other science. And currently there are some conflicts available. I'm not using the word war here. The conflicts are there. The technology is used massively within these conflicts, starting from Gaza. And when we come to Ukraine and Russia, and also America and Iran and Middle East conflict. So massively these technologies are used, starting from Iron Drone to missiles. So many technologies are involved in these type of the conflicts. And cyber war also happening behind it. And the whole globe is affected from these things, and that's one of the things I have to start here with the remarks, as well as when we think about the sustainability and the sustainability goals under those 17 items, and the climate change is one of the things we have to always talk about. And yesterday I was at UN one of the workshop, and I found that there were some things which are reported here. Things like, the biomass, the renewable biomass emissions which are happening, and as a fraction with the districts level within Sri Lanka. And I have seen that Badulla is reported with as a percentage of 45%. And highest was reported from Nuwara, and the lowest was from Jaffna. It's around 25%. And we have to think about how to reduce these type of things by using technology in the future. So at the same time, I take another type of remarks, and just a moment ago we had a keynote speech on cyber security and the cyber threats, and recently some of the incidents we have heard from media regarding the cyber threats and the cyber security activities which are happening within the country, and how the technology can be enhanced to protect our resources for the prosperity of the humankind, and not as a global, at least like Sri Lankan situation, we have to look forward into that level. Right. So with that, so we have 4 special panelists, and they are talking on 4 thematic areas, starting from Professor S. Vasantapriyan. He will be taking care of the area of cloud computing and cloud technologies for the future. And also we have Professor Roshan Ragel from Department of Computer Engineering, University of Peradeniya. He will be taking care of the AI and Gen AI and cognitive sciences within the technology. For the future technologies, what type of things we can do. And also we have Professor Pradeep Abegunwardana, Dean, Faculty of Computing, SLIIT. So he will be taking care of IoT and sensor devices and sensor technologies which are mainly targeting on agri-products and agri-sciences and the IoTs. And also we got Dr. Valikanda, Senior Lecturer, Faculty of Geomatics, Sabargama University. The sensor technologies and geosensing technologies and the future of geosensing technologies will be covered by him. And all 4 panel members I will come and we'll start the discussion now with that particular very brief introduction about the sustainability goals and the technological challenges what we are having currently. First, let's move with a round with a very introductory session from each and every thematic area. So let me start from Professor Ragil to pitch this introductory session for the 5 minutes each. I'm going to give 5 minutes each for the first round. And please start with the AI technologies and how that AI will evolve and what your expectation in the future, what that AI should do.
Thank you for having me, and good morning everyone. The idea what we are discussing is how different technologies and the sustainability and my responsibility to talk about AI. So just to understand, if you take a technology like AI or any other technology, and in addition to talking about the Sustainable Development Goals, which is global, we should also connect them to what's happening here, local in Sri Lanka, right? I'm happy to be at a university who is taking this seriously. I know Wellassa University takes the national relevance and the work, how it is connected. In fact, the way how it is set up, the university itself is set up, we see a lot of engagement and the drive towards national development. Starting from entrepreneurship and community engagement and various others. And therefore, I take this as a right opportunity to connect the Sustainable Development Goals on a particular technology, which is AI, to national development. How these 2 things can go together and how it's going to help us as a nation come up or come forward. Right, so that's what I'm going to talk. So that just to give you a background, and then particularly about AI, if you think about AI and sustainability, yes, AI can support sustainability, that is my belief, but at the same time AI also brings in sustainability challenges, right? So it's both sides. Like for example, the estimated power usage of AI systems by 2030 is 1 trillion watt-hour per year, right? So 1 trillion watt-hour, which is much more than this country's power requirement for a year, right? So that's sort of a power requirement. So that's just a starting point, right? So which is a challenge. Why it's a challenge? If you are going to use AI to improve things, make things better, we also had to worry about how we can sustain the technology that is going to do it, right? So that's a challenge. But at the same time, technology like AI, we should not look at it as, okay, it's something that can make things faster. Yes, it does. But make things faster, including the cyber-related things like it was discussed earlier, right? So with AI, we can also do nasty things faster, right? So good things faster, obviously, that's what we are discussing. So instead of only looking at how AI can do the right things faster, we should also see how we can use AI to like make things sustainable. Sustainability is not just about going forward fast, but also to make sure it's long run, right? So how do we reduce different type of resources, right? So how do you reduce waste? Like if you take examples, if you take a country like Sri Lanka, agriculture is an example. So if you take agriculture, how we can reduce the waste, how you can reduce the amount of fertilizers that we use and spoil or do things to the soil, and how we can reduce waste, food waste, or how we can reduce various other parts. So these are things that we can do now with AI. That is just an example for agriculture. So there can be many, like there are many other examples, even if you take education, right? So most of you are students. So how we can use a technology like this to learn better with less resources, right? So right now we have less resources, you might already know, right? So the universities are struggling to hire human resource, and we have limited resources. Even if you want to have better facilities, again we have limited resources in terms of funding. So can we use a technology like AI to mitigate this situation? Can we figure out ways to do things better with lesser resources, right? So the answer is yes, there are many things happening. So education is just another example. Agriculture I already mentioned. You can also think of other examples, medicine. And also, like if you take a country like ours, again we are sort of proud in the way how we handle medicine, although there are challenges. So we can, again, that is another area where we spend a lot of our funds, or taxpayer money, but can we do better? Can we do better when we integrate this sort of technology like AI? Right, so that's one more example. We can think of more examples like, another regular problem when it comes to mobility, when it comes to government services, is things like transportation or public services, other services. Can we improve them using AI technologies? Answer to all these questions is yes. At the same time, we also have to keep in mind, while we are using this technology, we are going to also touch on the sustainability side of it, because the technology itself requires more resources. Right? So there is a balance, there should be some optimization, some comparisons, some calculations to decide how to go forward. Right? So that's how I see it. Thank you.
Thank you very much for your nice introduction for the AI theme. And so I think you have spent maybe around 4 minutes, so still you can go for 5 minutes. Okay, so okay, right. So next I'll move to the next topic and the theme that is about cloud computing. And cloud computing also one of the challenge, and there are challenges produced by the cloud computing also there, and as well as there are some opportunities created by cloud computing, and that particular theme will be taken by Professor Vasantham Priyan. It's over to you.
Good morning. First of all, congratulations for the organizing team, technical team and publication team and the university for initiating this research culture in the faculty. I still can remember IMPETUS 2022, where the magazine was launched in the same premises. I came as one of the chief guests from IEEE Computer Society Sri Lanka chapter back in 2022. I see few audience are known to me, and it's a kind of a very used place. Thank you, Professor Jayalat, for inviting all of us to this one. So when I look at sustainability, as Dr. Lochandaka explained, sustainability always talking about development, responsibility, and long-term balance, right? So if what he covered is over there. So in my topic, if I say on cloud computing, sustainable cloud is not only energy efficient, but also we have to think about, as I said, responsibility, affordable, inclusive, secure, especially ethical. Now in the morning, someone was talking about ethical. And environmentally, also responsible. That's what I say, long-term balance. So we don't need to damage this global. Sorry. Can you move to the next slide? Next slide. Okay, so I can't see the slides from here, so I'll take my slides here. Okay. So if you look at the how this enables sustainability, So people think always cloud means it's just some servers or something like a remote resources we keep somewhere and people access. But behind this, we also should think about resource efficiency, scalable digital innovation, and inclusion and accessibility. Because why we move to the shared infrastructure? Because when we see our requirements, sometimes even here you see our servers, our local on-site devices have to be maintained on prompt, even on Sunday in a lightning day. A simple example, our power generator's backup is not working. So total LMS is out. So network manager to director to everyone is getting scolded by somebody. So why we cannot go as a pay-as-you-go scheme to find a solution where the university can afford a kind of that's what it is, pay-as-you-go. We don't need to go for as we see, but we can go as you say pay-as-you-go and see whether access, pay-as-you-go access, so that you can find some way of managing the budget and give our scalable solution for the need what it arises. So that's what I say, resource efficiency comes in. And as Professor Roshan started with AI, so it supports AI, and then my colleague Professor Pradeep is going to talk about IoT applications. So where are these massive data collections? You know the students, you know about that, you studied basic things over here. And the storage, and then processing, and real-time analytics for smarter decisions. Now we are talking about, if you have not a scalable solutions, how we are going to take a data-driven decisions? From where? Even in the university systems like that, do we have a place where we see a digitalized meeting minutes in a place? We talk about so many things. We build buildings, air conditions, boardrooms everywhere. But are we looking at a kind of a sustainable solutions to develop the university? No. A very basic meeting minutes, right? It's not even shared everywhere, right? There are places where we are still struggling to do because of the ethics and environmental issues are there, right? Move to the next slide, please. So these are good examples where Professor Roshan also started about smart agriculture. See, a lot of agriculture people are in front of me. So see what happens in agriculture. IoT sensors collect soil and weather data. Some of the mini projects, some kind of a community project, students might have done it already, right? Water, you see in the district where I work, in Ratnapura, and my colleague Duminda also going to talk on this, water contamination, earth slips, where the data is there. So the sensors are going to take the data, right? And where it's going to be stored in a cloud to take the faster decisions, to work with the people. So if some water contamination happens remote in that particular flooding, the people should immediately get an alert. By an experimental device, it has to send quick alerts. So how this happens? So how cloud helps? Smart energy, smart campus. We always talk about smart energy and smart campus. Even see when you go across these things, fans are working, lecture lights are on, projector is on, but we don't think about it's still not smart. But we present smart university, this is smart, this is what we do, right? So what is happening there? If we have some kind of data-driven decisions from this, lower energy consumption, better efficiency, and can manage our resources. I know the university is paying maybe 3, 4, 5 millions of rupees for electricity per month. Remote education and healthcare, at least most of the students at least come to this point because remote education happened all the way since 2020 when the COVID came in, everybody got into this remote education. At least we heard only about the distance education. Sometimes some people say Open University is doing or this one is doing. That's what we heard in the beginning. Now we implemented that in our own daily life. Even one lecturer is not here today trying to do something with the remote teaching. See how technology helped us, right? So more equitable access and low environmental burden. Okay, skip Ilang slide. So if you see the diagram, what I clearly said, resource efficiency, sustainable solutions, and inclusion and scale, right? If you look at the resource efficiency is very important first as it is. So that's why shared infrastructure always is very reasonable to remove these duplicate servers. Even in the university itself, just imagine every faculty is having servers at different locations. How much we spent. Virtualization we talk about, but we never do it. We never implement in our universities or in our office premises, right? So we should think about this once again, resource efficiency. Enabler for sustainable solutions, of course now powers AI and IoT applications at scalable. Smart grids, Professor Pradeep might be saying something on that. Precision agriculture audience are there. Disaster monitoring, of course, which is really important for all of us. So students, look at a possibility of developing projects, innovative projects, looking at these sustainable solutions, right? Produce some sustainable solutions where the future vendors may look at and can go for a larger industry level solutions later. As I say, pay-as-you-go access is very nice for universities. What only you want to put, you can put it as online. Otherwise, on-site is quite enough accordingly, right? Especially when it comes to, because I work in the digital ministry with the, this curriculum reform in grade 6 to 13. They are thinking of placing all the materials to cloud. ieeeuwu is one good example, right? And they are still thinking about having a larger scale accessibility solutions for the students, right? So it is, in this way we can start the conversation today. Thank you. Excuse me.
Thank you very much, Professor Vasantapriyan, and I think he has used a little bit more time compared to our earlier panelists. Actually, based on his presentation, what we can see is that cloud computing can contribute to the sustainable development goals, and as well as we have to do it with the design and implementation with responsibly, or maybe with proper design. Okay, let's move to our next panelist, Professor Abe Gunawardena. Actually, you are going to talk on the IoT and the use of IoT, Internet of Things and sensors for the sustainability goals to be achieved within in the future. Right.
Good morning. Good morning. I think you can hear me. Yeah. First of all, I think I would like to take your focus on the IoT industry in the today global, and hope you know that it's around 21 to 22 billion connected devices around there. Even some of you might have smartphones, so even without knowing or without knowing, you are connected to the world. And plus, I think its current market share is around 500 to 550 billion US dollars in the current. So you might, some of you know actually, so you might think, what is IoT? Probably, so if you go to the definition, it's actually It's actually physical objects connected to the network through software and the internet connectivity. So we will have these kind of things. Basically, there are 4 components here. You know that the getting data, as we all see our things through our 5 organs, visual, hearing and everything. So things needed to come to the system through some of the devices. Those are called sensors. Probably there are a vast variety of sensors right now around the world. Even in your projects, you might use these kind of developing these kinds of sensors and things for the IoT industry. And second most important is the connectivity. I think now with the recent video that the government has initiated the expanding the connectivity across the globe, and more soon we will have the 5G around across the Sri Lanka. So those connectivities very matter, because once you get the data, you have to push something to the cloud or somewhere else to process. And so just taking the data is not enough. You need to have a meaningful data. So for that, you need to process and maybe improve those things, kind of pre-processing, and arrange those things. So processing is important. And once you have all these things, say through sensor you get data and you send it to somewhere and you have the processing technique, but having all these things is useless. Therefore, it's need some action to be taken. So that is also a very important part. So when you do some IoT project or anything, so maybe what you have to do is think about what action that people can take in future. Those 4 areas are very important. And if you talk to the sustainable goal, actually you know that the second goal of the sustainability goal is the hunger, zero hunger. So where we can have that link with again the smart or precision agriculture and farming. So we all need enough food. I think you know that right now it's around more than 600 billion population, and it's going to increase in future as well. And current state says that I think 28% of food are already wasted by people, human. So therefore you need to reduce those things while developing the agriculture. So you need to develop those things. So there are 2 areas here: precision agriculture we can use, and as reducing waste. Maybe clean water and sustainable smart sustainability is other area. So basically it's probably our next panel member, Dr. Dumindo, also will talk about the clean water. Hopefully what we can do is, so water quality measurement is one of the areas. So some of you might have already developed the product for this, and that is already linked to the sustainable goal 6. And also affordable energy and clean energy. And you know that right now we are mostly talking about with this energy crisis and fuel crisis, the solar energy. And we will come back to later why it's not practically difficult right now. Not impossible, it's possible, but practically difficult. So we need to have clean energy, maybe taken through renewable energy sources, and should maintain and utilize those things well. And maybe climate is the other issue, so probably climate monitoring and a lot of the areas are there. The climate is always data came in a few months back, and I believe that you might be hard area that has some impactful or the hard hit area. So for those things, so you need to be prepared. The preparedness is very important. In terms of the climate, disaster mitigation and disaster management is also there. The preparedness, monitoring, and those things are there. All these areas, what we need to do is basically monitoring through sensing, and the connectivity is very important when you have the disaster and kind of things, smart farming, those things. So there are a couple of new areas like LoRa network and those things. When you do not have the service provider connectivity, those areas are there. Those are some of the areas. I think we will, in next round of, we will take few examples and we'll take discussion. Right now, I think from the IoT domain, there are a lot of SDG goals that we directly contribute, that we can make the sustainability of human as well. So at the end of the day, what we need is a comfortable living without harming the world as well. So in that sense, I believe that IoT, sensors, data connectivity, data processing and action. So those areas have immensely contributed, and with that, I think we can continue the discussion in next round.
Thank you very much, Professor Pradeep, for your nice introduction about the IoT, and that is about sensing, the measuring, and then the reporting and the connecting with the data, and also the data centralization and processing and decision making can be done, and that is what he has explained and nicely explained that one. And let me move to our last panelist, that is Dr. Duminder. Dr. Duminder is going to talk on the remote sensing and maybe satellite-based communication and the sensing technologies, how those sensing technologies can be used for the achieving sustainable development goals as well as the future of that particular area.
Thank you, Dr. Lochan, and good afternoon, everyone. I want to thank Professor Jailath for inviting me here. I'm not in your cluster. I'm basically a remote sensing person, a data scientist. But one thing about your conference, I like this word, humanity first. I have to appreciate that, because I'm going to quote 2 days back, Pope Leo said this about AI. So-called artificial intelligence do not undergo experiences, do not possess a body, do not feel joy or pain, do not mature through relationships, and do not know from within what love, work, friendship, or responsibility mean. That is what he said about AI, right? 2 days back. So we are talking about sustainability and computing, AI and all. So my area is basically data, all right? Remote sensing and GIS. So many of you might have worked on these things, because observation satellites are all over the place. It is an IoT, right, as Professor Pradeep talked about. It sends humongous amount of data to us, and we need computerized models, intelligence, to make them interpretable for people and to make information coming from those satellites go and make life better. So we talk about sustainable goals. So how can sustainability be enhanced by these satellite missions that is hovering around us? One example I want to say, I know that Professor Jailath is heading a particular project for Wuwa province, your province, right? The objective is to have safe transportation system, right? So what we are doing right now is collecting data. We already have the algorithms in place to understand what sort of disasters are affecting these transportation systems. So we go for spaceborne satellites, airborne drones, and we collect data, right? And then the intelligence part comes in. So we humans, from our childhood, learning ABCs 1, 2, 3, we have developed our intelligence for a long period of time. We learn mathematics, we learn science, we learn history, everything. All right, so AI comes in and plays that part for us. But still, we cannot leave a set of data that is very, very, very useful and very complex, just simply on the hand of AI. For me, I have, though I talk to you about remote sensing and AI, I have not applied AI completely by myself, but I was a deep learning and machine learning guy. But I never had that leap from machine learning to the AI. I don't think I had that still, right? Because I doubt sometimes leaving my data, because satellites are measuring us. Those are not images, those are not pictures, these are measurements. GPS is a measurement. Synthetic aperture radar is a measurement. Every pixel is a measurement. It's a raster data set, it's a matrix, and we need algorithms to interpret those into information. Landslides, right? Safe cities, sustainable goals, precision agriculture, hunger-free societies, sustainable goals, right? Illegal poaching in the forest, habitat loss of the elephants. All these things are possible with Earth observation satellite information. There are many satellites around us, and we need to know how to get those data and convert them into useful information, because all of us, we do science. But in the end, if it does not reach the poor people and make their life better, sustainability will not be reached. So that is what we are talking about here. So I would like to talk about whatever the interesting matters, especially related to these remote sensing and geographic information science related models that give useful information for policy decisions and making sustainability a word that we can someday think about that we have reached. So, yeah, thank you.
Thank you very much, Dr. Duminda, for a nice introduction to this remote sensing. Actually, that is one of the technology we can see that we can reduce some of the emissions, like we don't have to travel to get the data and measurements, and remotely we can do that. So that's a nice introduction. And so that is the end of the first panel, the introductory session of the all 4 thematic areas. Now let's move to the next part, that is about asking questions. So I have a few questions in my mind, and I would throw them into our panelists and get those answers and clarifications. And actually, each and every panelist, I'll ask 2 questions within this round. And I think better to ask it maybe one after the other, or maybe together I will ask the question, both questions together, then the panelists can brief the answer by connecting them. So, Professor Ragel, I know that you are part of the National AI Strategic Committee or Strategy Development Committee as well, and also you have done many publications on the Gen AI and AI related research. And so, based on your idea, where does AI really fit in the sustainable technology? And as you said earlier, I refer to your statement. So I feel it like every action that we do in this AI tools, like Gen AI tools like ChatGPT or maybe Gemini. So everything what you search is a matter, because it's even though you do not feel there is a kind of emission happening that as you feel. Now, so there is a kind of a negative impact and the positive impact also there. So based on that, where does AI really fit sustainable technology? And is AI itself sustainable? Or is it a tool, only a tool? And that is my first question. And I know that there are a few sub-questions available in that first question. And the second one is about how AI supports Sri Lanka's economic growth, and how can we use that AI as a kind of a tool for the economic growth and national productivity improvements. So those are the 2 questions.
Do I get 10 minutes or 5?
You can take maybe around 8 minutes.
Okay, right. So thank you for that question. In fact, I touched upon the first question a bit, that is about generally about sustainability and AI, the challenges. So just to remind you, what I said last time was, if you take a technology like AI, the estimated power usage, just the power usage, is by 2030, 1,000 terawatts per hour. Terawatts hour, not per hour. It's a lot of power. And because you mentioned about, we had to be a bit concerned about using it and prompting and all that, I can also give you some stats about it, just for fun and also seriousness. OpenAI did a study on how much power they consume for processing prompts, inferencing, like processing prompts. Let's say you do a prompt to generate a 1-page or a 100-word email. I'm sure all of you are preparing emails using AI, generative AI, because I get enough and more emails where it says, put your name here, right? So, so these, even yesterday or day before I received one. So these emails, when you are generating just a 100-word email, the estimated power consumption, this is from a bit older stat from GPT 3.5 or some version. For 100-word document, 100-word text, to generate it, it consumes about 140 watts power. 140 watts hour, which is equivalent to lighting about, if you take this, the LED bulbs now, about 14 LED bulbs for 1 hour, right? So 14 LED bulbs for 1 hour, it's just gone if you do a 100-word email prompt, right? A prompt to generate 100-word email. So how many of those you are generating? Obviously, it's not a bad thing to do as well, right? Why it's not a bad thing to do is I'll also tell you the other side of it. If not, you are going to sit and write that email. How long will you take? Maybe half an hour, maybe 1 hour. If you are sitting and writing in a half an hour, you are going to use a computer. If you are want to be comfortable, you'll also sit in an AC room and write it, right? So again, it's a balance. That is what I am trying to say. So the AC, the power of a computer, person sitting and doing, will also consume power. It's not that generative AI generating 100-word email is the only thing that consumes power. There's both sides. So we'll have to understand both sides, right? So this is just to give you some glimpse, and you can go and find many of these statistics and for both sides everywhere, right? So that's the starting point. Like I said, we'll have to look at how, first thing, the question is, okay, AI itself, is it sustainable? That is what we are discussing here. We are bringing in a technology. Is it a sustainable technology? Can it last longer and be useful for the longer run without breaking this planet, right? So that's the question one. So what the quick wins, what we can do faster in parallel is also to use this technology to do things better. Right? I mentioned this earlier as well. Do things better, do things faster. Let's assume, in fact, the question I asked earlier about writing emails or writing a page of document, the recent studies show if somebody is sitting and writing, particularly in a developed country, Western Europe, US, they spend about 10 times more energy for them writing compared to generative AI, right? In the Western country. The study also compared it with India, not Sri Lanka. Hope we are similar in terms of power consumption. So in Sri Lanka, India, it's just 2 times. We consume less power for writing. Obviously, if you are sitting in a room like this and use AC to the lowest level where we are still sweating, then it's yes, right? So we are saving power, right? So, and we are doing productivity better, right? So that's just the side, like the side of where the technology is and so on. But how can we use it, use these technologies to reduce our waste, do things better, faster, so that we can sustain everything else. I already mentioned education, I gave example, and other places I gave example. So these places are where we can see as entrepreneurs, as those who are contributing to this technology, can we bring in applications, or can we redesign, rethink how we do work, how we build application, how we solve problem, rethink in the context of AI. Right? Can we bring it in so that we can do them better, we can do them faster. So like I told you, that email example, although I gave it as a negative example, it is a positive example if you study it properly, right? At least within the context what we are bringing in, like, okay, people sitting and writing, AI doing it. So obviously that is again like a very, surface level example where we are not going into deep, because an AI can't just, if you just generate it and send it to me, it's wrong, right? That's what I said, like you are not putting it even your name, right? So you also have to get involved. So we'll have to look at it more detail, spend time, and redesign, rethink of applications, how we can do it properly. Every field you can find examples, applications, where such things can be done. We can do better, right? So that's the starting point on AI, whether it's sustainable. Can AI be used to sustain any one of the sustainable development goals? Right? Can we make it better, or can we achieve those goals? As you know, those goals are not achieved. We want to achieve them, we put a deadline, and we are planning on extending the deadline and so on, right? So that's where we are. So that's that. But at the same time, a country like Sri Lanka, like I mentioned earlier, that's the second part of the question, where how we see any digital technology, including AI. So AI is sort of new to the common, but any digital technology, how we can use it to economically develop, how we can use it to become better, become richer as a nation, or become affluent as a nation. Right, so that is where we are looking at it from like a digital transformation. As you all know, we have the current government has introduced digital transformation or digital economy as a separate main arm, where we wanted to look at how we can improve the country's economy using digitalization or digital transformation, to be exact. Right, so how their AI can come in is, I think we should see AI as a productivity tool, yes, not just as a chatbot, but how it can be something that improve productivity, improve our economic value. So AI is intelligence, yes, it has artificial intelligence. So can we use AI to improve the level of intelligence of this nation? That is what developed nations are looking at. That is what those who want to develop are looking at. Can we look at a nation as a whole? Nation basically is people, right? It's just a concept, right? So can we look at AI as something where we can add to our intelligence, collective intelligence, so that we can come up, we can come better. So if we are better in an economy where there is, it is mostly driven by things like intelligence, it's possible for us to come up, come better, develop our economy, develop our, in the lowest, in terms of numbers, GDP per capita, and so on, can we improve, right? So these are things that we want to do. In fact, big agencies like McKinsey has estimated AI globally will add about $5 trillion every year to the economy. $5 trillion. As you might know, Sri Lanka's GDP, annual GDP is $100 billion. 100. This is 5 trillion, 5,000 billion. Right? So a small portion of it, we can become a developed country. Right? So obviously, it's a lot of challenge, but can we do it? Can we take it to that direction? Can we make use of it? Something on that positive note is, like last week I saw Slash.com is celebrating that they have become above T for export, right? In terms of the last quarter, the Slash.com, as you might know, is the agency for all software and BP related, so processing related industry. They are claiming that they are now, I think, the third largest exporters. So that is in the right direction, I'm saying, in terms of things like technology, AI, right? So those are examples and possibilities that we have. So we should look at AI as a productivity tool, and therefore we'll have to see situations where we can improve and come forward with it. I see the case moving, which means I'm going over time, so I'll stop.
Okay, thank you for good understanding. Right, okay, so the AI can be used, but you have to use it consciously, what you can do without much energy waste of, things you can do by yourself, and some of the things you can use the AI That's what the key message. And let's move to Professor Vashantapriya now. Earlier also you talk about the cloud computing, and we are having data centers, right? We are coming into the data centers most of the time in such situations. And do you think that the data centers are energy efficient, and that is a kind of a sustainable for the sustainable activity to do when we are concerning about the sustainable development goals? And the first question is that. The second one I will ask again, that is about, there are things like policies in the sense, if you look at Sri Lanka, we had our Personal Data Protection Act in 2023. And also different countries are having the law enforcement differently. And the data sovereignty problems are also there when we are hosting the things in the different data centers outside the territory. And with that, what are the policies which we are expecting for the future for sustainability of the people within Sri Lanka and also different countries? So over to you, Flospriya. And take only 5 minutes here.
Thank you. So for the first question is about, we are talking about cloud computing, and you mean like huge energy is taken up. But as I presented in the previous session round, I mentioned rather than having scattered servers even in a university. Now look at, if you go to the university servers, now most of the audience are computing related, go to the server room, the servers are running, the power is consumed, but you see the percentage of usage utilization there, maybe 5% to 8%. Because one of the LMS is used, or one of the services is used. But the device needs power, device needs cooling. Cooling means what? The whole room needs air condition, right? So just imagine a human is needed to monitor that over time, to day to night, right? 24 hours. So cloud, when we think about the cloud, so this like this scattered and scattered and scattered, you see the points. Now if we can put the dots in the country, in this province we have few dots. But if you go to the Colombo, everywhere dots, because every building has servers running. Right? If you think about the cloud solutions then, if these dots are vanished and there will be somewhere remote, only one huge dot where they exist there. So scattered problem is solved at that point, and that reduces this, supports the sustainability. And when it comes to energy efficient, now there is also energy efficient we are talking about. The very good example is we are now this government, even they are talking about energy. The environmental ministry, power ministry are talking about energy. Solar energy is there. We got wind energy. Now I see last day also some turbine brought from ships from abroad. Hydropower, what we had already. We talk about ocean energy. We have to promote this ocean energy, I think, because we are surrounded with ocean. We can use ocean energy to generate electricity. There are techniques. Now, I still remember back in 2000 when we studied in Netherlands, including this Duminda was there. Back in 2017, the national transport in Netherlands have decided and we call that as a railway transport. They are going to the solar energy, right? Already, whole stations and the train. You go and see, it's a very huge success what they did. So that's why they grown to that level, because they implement solutions rather than discussing in the forums, right? So energy is I told you something like energy efficient is really important. So the cloud centers can apply these energy efficient mechanisms. And as I said, AI is here, IoT is in the left side. Both these people can help to run this energy efficient monitoring to facilitating. So like a single server in a room doesn't have energy efficient, as I said, right? Then we always talk about the green. So green is not like just keep running, minimizing, right? So efficient cooling. Now you see server rooms are now early days. Some now I have seen some universities, some centers, even the servers rooms are running with self-cooling server cabinets. That cabinets itself having the server cooling, self-cooling, right? Because that's the best way of solution. So innovators are finding solutions because rather than the air conditioning the whole premises, they have the self-cooling. So why it's an efficient mechanism. So we ask, that's why the audience here, you should find out what you learn from theory to apply something and find solutions. Right? Faculties and universities are funding for that. So this is what I said, the cloud, how become energy. And the other question is really interesting question, and it's really important for all of us. But what we missed is always we talk about applications and solutions, but we never come to a one framework or a kind of a policy. So when you look at the policy, especially, who is responsible? Now, I know the data is going to be somewhere else, as I got into my previous explanation. So who is going to access this data, right? Who is going to keep this, allow the parties to visible the data? Now I can still remember in Sri Lanka, still only one and only ministry still didn't try any digitalization which is legal ministry. Why? If you digitalize, everyone can, if the things are gone out, the whole things can be challenged sometimes because the documents are very sensitive, right? Even the health records, you see, most of the time, these data should be kept very clearly. And data sovereignty, I think you are talking about data sovereignty, so protect the data sovereignty always. Then other one is also, now we talk about the policies we should create that universities, especially the startups, public institutions, to come up with accessing services affordably. That's what I say, pay as you access. Otherwise, what happens now, after some time, everybody wants to have cloud solutions to use, but we spend money. So we need to have affordability there. That's what I said in the SDG in the morning when I was explaining sustainability, development, responsibility, plus long-term balance. That is why I said in cloud, in my context, having affordable, inclusive, and secure and ethical, and also environmental responsible to see as an sustainable cloud solution in our community. Thank you.
Thank you very much, Professor Brian. I think there is cloud providers also having these, the elastic servers and those type of stuff, and the energy saving methods are there. So those are the things you are mentioning, right? Thank you very much. And let's move to Professor Pradeep and actually the IoT. So IoT is providing a lot of services for the different technologies, and you are talking on agriculture, but I would like to take your attention on some other areas also within my questions actually. The first one is about in Sri Lanka, are we using precision agriculture technologies, and what type of technologies are employed, and in the future where we can apply the precision agriculture into practice in different areas of country? That is my first question, right? The second question is about now the disaster part. So the disasters are always one of the problem we are facing, and the Ditwa happened recently, and also recently there was a Kalaniganga, there was a problem. And so how can we use this IoT for these type of problems to be detected, or maybe early warning type of situations, and what type of technologies can be applied, and are we applying currently those type of things? That is my second question.
Okay, thank you very much for the question. Actually, so these two topics are very sensitive as Sri Lankan, and you know that the precision agriculture is we shift our traditional agriculture to do more towards sensing, data-driven and smart farming technologies. And so if you talk about the current situation, I think so we have been working a few years back to increase the precision agriculture. As you know the world situation, I think you might know that Israel is the country. They have applied this, improved this area in a much better way. And so during past, actually, if you think about, talk about Sri Lankan situation, and basically to enhance these things, we need some platforms to gather data and just to communicate. And so some of the ministries are working from 2019-18. And personally, I also involved in one project when I was in ICTA. So working there to bring Bill and Melinda Gates Foundation to Sri Lanka. And we travel all over the country and so many visited so many places to just to confirm that we are ready with this kind of thing. And with that, actually, they awarded, and right now the current government is using that fund to enhance some of the decision-driven platform for countries. As companies and as individuals, I think what we can do is, so you are doing a lot of the agricultural product, maybe soil monitoring, environment monitoring, robotics applications, and so many things as undergraduate projects. It's our responsibility to just not to stop just after the project. And because so if you initially you develop your concept and prototype during the university, but that should be useful for the farmers in Sri Lanka. Go to the farmers and see their requirement and at least try to develop some of the product and IoT product for them to use. And in Sri Lanka, there are a couple of companies, and they are really doing, I think, one big company I would highlight here is the Icon Space. They have the company called LPT Plantation. So in early years in Sri Lanka, we didn't see much of strawberries and blueberries, but they use these technologies to cultivate strawberries and blueberries. Now, if you go to the supermarkets, you can see their product, and people can buy even though they're a little bit expensive. And when it comes to the companies, I think like you, there are good companies who came up from from their initial design, and one would say, if I say this name, so I think it's justice to them also. Sense Agro is the couple of undergraduate who got together a couple of years ago, and now they are doing well, and even going to the market like Australia to partners and Japan. So that is they monitor the open farming, like that mango and other open farmings. So basically those the farming, we need to put fertilizer and the water enough amount at the right time. So therefore they monitor those fertilizer, the soil moisture level and the fertilizer level through sensors, and then help to the dry farmers. And second, I think one more is the algorithmic, and they are supporting the plantation. Those are also the young people like you. I think what you have to think, decide, and we have the capability, and we have to go for that one. So when it comes to personally, I think we have for our research and university, we have developed the one single unit for soil monitoring. So basically NPK level and the moisture level can be developed, and we through our project we distributed around 100 units to the farmers in Gampaha areas. Probably they are using, and we are gathering those data for the further improvement. When it comes to disaster mitigation, I think the most problem that we face during the Ditwa, so connectivity. So some of the villages in the, I think Kotmal area is isolated, and it took 3 days to get some information from them. That is, if I am correct, the Hutch is the bus to get there and connect to their network and create the connectivity. So, as an undergraduate project, what we are, so research project we are doing right now, personally I'm also involved in. So service provider pre-communication techniques that we are developing. So a lot of the enough signals are there, how we can capture those signals and extract to unplace and improve those things. And in terms of sensing, I don't know that even when we are coming after the refreshment, we saw that this university is built in the really hilly area. I don't know whether you are monitoring the soil structure, the shear forces and everything in the current situation. But sometimes we might face difficulties. But why not you develop a sustainable system for the university and give some idea about the behavior, probably about the soil conditions. And so what right now, personally, I think we have developed the earthquake monitoring sensor using the IoT technologies. And so we already deployed and tested with the New Zealand partners, and we got around 40 orders to deploy there. And also one of our undergraduate student who developed the tiny ML algorithms, because disaster situation, we have small devices, we don't have enough power and enough processing. But just to communicate, you need to extract enough information and communicate. For that, some undergraduate people develop the tiny ML algorithms, and they publish those things. So those kind of areas are there in the disaster. Probably main thing is agriculture. Just you know that right now we are focusing on the monitoring disease detection and those things, but beyond that, go to the analytical level, find out what kind of the support that the farmers can be given. In the disaster situation also, do not look at the simple things that we are seeing around us, but think beyond that one. Before finishing, I think I will get one small example. You know that Paris Agreement is to reduce the carbon footprint. So they are, so one of the Sri Lankan company, the person who stepped into the domain and developed system to support, to monitor the carbon usages of each companies. And it's a multinational company operating in the port city right now. And those kind of the untouched area, touch untouched areas and go ahead. That's the message, I think. Thank you.
Thank you very much, Professor Pradeep. I think there are multidisciplinary studies and multidisciplinary contributions from IoT, and here in this university you have multiple faculties, and those disciplines like agriculture and geoscience, all these things are available within this university, so that there's a big opportunity for these students to get involved in those areas and come up with different ideas. Okay, let's move to the next panelist, Dr. Duminda. Dr. Duminda, you talk about the remote sensing, and now in Sri Lanka, there are different departments normally applied these techniques and the satellite images or satellite multispectral images for identifying different species and different areas, and the mapping, basically for mapping land use policy planning department and the forest department, they are applying it. And in the future, what are the other areas we can use these technologies for to achieve the sustainable development goals, and also to protect or maybe improve the prosperity of the humankind within Sri Lanka and also planet?
Probably the universities. Other than the sectors should take the hand, because there are many departments, as you said very correctly, but the data sharing and data interoperability is not there, right? So what happened is, actually in Sri Lanka, I know for a fact there is a massive loss of data without being used, probably from the survey department, right? As far as I know, terabytes of satellite data is there without being processed. Now the thing is that why we talk about this remote sensing. I have seen in the book there are many machine learning and AI algorithms being applied for patient data and medical data. They are very nice, right? And so students are doing these things inside the universities, but the thing is that they are not much exposed to this position-related data, right? Position provide you very powerful information. That's why satellite images are very important. The amount of enhancement in remote sensing is now, it is not merely an image. It can measure deformation, and I'm happy to learn about the ground movement sensors that Professor Pradeep had developed, because it can be calibrated with satellite data. So that is an interesting work that we can do, and I would like to purchase one for my university as well, because that is how we have to collaborate and enhance ourselves. This is where we have to lead. We have to push our own scientist products within the country first. I believe that they should be promoted. Universities should come together with ground sensors. Ground motion sensors should not be first identified from Canada and bring it in, and once the batteries are gone, you need 2 million to send it back. No, that is not going to work for our country. Our people are very intelligent. So that's what I am saying, that exposed to these information, positional information, wind measurement is there. So as Professor Priyan was saying about ocean, and one of my main interests, you know, the climatic changes, and it is harming our sustainability, and we don't have a marine monitoring system. And if the government wants where to build the wind wind energy stations in the sea, where we can harvest those winds, we can detect those wind patterns using synthetic aperture radar satellite data, right? And there is a special satellite from European Space Agency called ieeeuwu, which is, the meaning of Greek is the god of wind, right? It is there, and it is not possible for us to purchase it free. It measures the wind changes on the surface, on the atmosphere, right? And we have gray satellites, which is free, and it detects gravity. We are the lowest gravity country in the world. I have proposed through your Vice Chancellor to Japan to have space launching data, because why? It is 1/6 of the gravity of launching a rocket from California. That if we launch it from Unawatuna, it will be 1/6 of the cost. That is a huge amount of benefit for us, right? But these things cannot be done by personal correspondence with those agencies like JAXA. It should go through government to government. So I don't know when these things will be realized. But these ideas came to me by using satellite positional information. That's why I know that. I have made gravity maps, and I know that, right? So they shows us information about ourselves, where we are living, and how we can make our geography, because we are just 6 degrees above the equator, and it is very difficult to monitor our country because we don't have seasons of beautiful weather all throughout the year, but we have 2 monsoons, 2 intermonsoons, so we are mostly cloud covered. So we need special satellites to detect our area. So we are doing that now. Not we. I'm talking about remote sensing like I have sent satellite. No, I am doing the most basic part of remote sensing. Right? People who have sent satellites are doing the real part of these IoTs. So what I'm asking you for your question is that universities should take up this. Use more of this position. We call them spatial data because each point has a position. You know when position goes wrong, what happened? You have seen that in Iran. I'm not going to talk about that, right? The devastation that happened in a school, right? Pattern recognition through AI, where Pope is saying it doesn't know responsibility. Just imagine you are an engineer, you are given a task to mark the center line for a new highway. You are going to be very responsible on that matter, because you know why? If you mark it on another side where 100 of houses have to be demolished for the new road. But then after that, you find your coordinates or positions are wrong. You have to take it to the other side, and it is a forest. You have already demolished 100 families. You are responsible for that. So you have to be responsible for what we are doing. And intelligence should be responsible. That's why I'm saying, so universities are the right place to take this up, to take this information, push students, make business models. I have heard Professor Pradeep's talk about business models. I don't know about business models, but these things can be made business models, right? So combining them, I think we are a very good way forward.
Thank you very much, Dr. Tuminda, for your nice answer given. And key items I took from you are, one is sharing the data, maybe responsibly with some kind of, restrictions as well. And the other thing is, without knowing us, our data may be going out because those satellites are not ours, and they know where the things are. And even that has happened to some of the countries like Iran, right? So without knowing to you, your identity and your data and everything may be available in somewhere. That type of things are available with you, and other thing is we have to promote our things, right? That's okay. So with that, and we had a kind of a round of questions, and I would like to open up our audience also. Maybe they are having some painful questions, and there are maybe curious things to be asked. So I would like to open up the panel for a few questions from the audience, and use this opportunity. And only we can give only few questions to be asked here because with the time constraints. Don't keep your question with you. Please ask those questions.
Thank you very much for nice discussion. Actually, you reveal lots of valuable information. Actually, this is not a question, but so as Dr. Tuminda said that there are lots of data, especially satellite data. So we need to process them and convert them into information. So what kind of strategies as universities can do these things, right? That's I'm asking from the panel.
I think Dr. Tuminda in particularly, you address it, and also others also can contribute to that particular question. How that particular data now which are available openly, for example, the Sentinel satellite data is openly available, and some of the other satellite, also the Meteosat and those type of stuff are there. So in such situation, how can we use that for the processing?
So what can,
Thank you, sir, for the question. It's very important. Actually, personally, I really don't know how to answer that, right? Because the thing, I have been working with several government institutions, you also. You know the circumstances that we had to face on sharing data, because they have their own rules and regulations over data, for which they have not expressed why they have put those regulations or rules over data. We don't know. There are no perfect reasons for them. So what I'm saying is that there should be a discussion at a very high level, including all the universities in the country, that all these the data that the government institutions are buying from public money should be shared with education institutions. For instance, I would like to share a very personal information from Survey Department. In somewhere around 2000, they did Japanese by use with JICA funded project. They mapped the Colombo and Kandy region using LiDAR airborne aircraft. to get the profile. Those data was never shared with anybody, but it was shared with a US university. Right? It was never shared with any of the universities of Sri Lanka, but it was shared with Ohio State University. Right? So that is how things are happening. So that's why I'm saying universities should pressure, because these are public money. They are buying satellite images not from their pocket. They are buying it from public money, grants and all. It belongs to people of Sri Lanka. And if those data comes to Sri Lanka universities, I think they have much more freedom to go around. So that's what I believe from mine. That's all I can say, but it's very difficult.
Yeah, I wanted to extend the discussion a little further. So data, we are talking specifically about data collected by government agencies. As you might know, even things like our Census and Statistics Department collected a lot of data even recently. And we are also trying to figure out, and also the Data Protection Authority, there are discussions on how some policies to set up where taxpayers' money is used for data collection, how it can be shared, right? So if you take Census and Statistics, they are not saying they won't share. But the current trend is that you make it difficult so that you don't get it, right? So not that you just say no. But I mean, things are changing, I think. So that's one side of the coin, but then there's more. Because there are a lot of students, I also wanted to highlight the more part of it, right? So the more part of it is, like everyone who is doing a project, a research, I'm sure most of the projects that are going to be presented today afternoon will have a data component, right? Whatever the research it is, there is data component, right? So usually our trend is to find data from somewhere. Our students go to the internet, find data to solve a problem. Think carefully. If you are finding such data and solving a problem, you are solving the problem of the people who put that data. You are not solving your problem, or you are not solving our problem, right? So something that all of you had to do, if you are thinking of doing a project, you have access to, yes, satellite data maybe is difficult, maybe it's available, more challenges, but depends on the project, right? So depends on the project, you can find, like for example, let's say it's about some agriculture. You go out and figure out how to collect the data properly that you can use, you can share with others within the country or public. Let's put it public. So that someone in some other country, Priyan was talking about Netherlands, someone in Netherlands, let them take it and solve our problem, if you put it out, right? So we have to look at it from a different angle, and also those who are looking for data, stop looking for it, start collecting, curating, and put them out, right? So this is for smaller set. Yeah, I'm not asking you to buy a satellite and send them around, but there is enough other things, even IoT. We can collect a lot of data here. So when you want to start a project, please think about it. Think about collecting data and solving problem, not just solving problem, right? So solving problem, maybe yes, you are coming up with a better algorithm, better technique, better whatever, right? Statistical method. Yes, that is good, but at the same time, it won't solve our problem, right? So, yeah.
Okay, thank you very much for that answers given to the question raised by Professor Jailat. So we can take a few more questions. Maybe one or two from the students.
Thank you very much for nice discussion, and it's very fruitful. And I need to highlight few things which is mentioned during your discussion. And one is solar energy. So we implement solar panel by the faculty last year, and save 1.5 million rupees per month from last month. So we initiated that one in last year. And you mentioned about the minutes. So we printed only 3 hard copies during the faculty boards. It's only for the deans and HODs. So other also are the soft copies. And another important point you mentioned is smart teaching. So we offer MIT degree programs. It's a fully online. And again, we offer the BSc external degree. Again, we use some online method and discussion type. So we always try to go for the sustainability by the faculty. So we had taken several such initiation. So I will go to the question part, like remote sensing. So as a coastal and marine geologist, I also did several things using the Landsat and central data. And we measured coastal erosion, so during last 20 years in Sri Lanka. And so this is applied in several coastal conservation department and other government organizations. They use those data for their decision making. And recently we did another project to identify sea surface temperature and chlorophyll, again using the satellite data. For especially some USGS satellite data, this is the there is a possibility, so we can get the high resolution data by requesting through the university email. So there is a possibility. So I got the all data from USGS free of charge. So there is a possibility. So if we can contact them, so there is a possibility to take all the data free of charge. So based on that one, we did several data, several investigation like I mentioned. So my question is there any, I'm not specialized in computing, is there any techniques developed to identify some oceanographic conditions, some sensors, like to understand waves, energy, or waves speed? So is there any possibility to develop that kind of some tools using IoT?
Yeah, I think so. Thank you very much for the question. The ocean waves and it's basically wave propagation. There are multiple ways of small sensors that we can detect the wave propagation even in the water. What we can do is to, with the application, integrate and develop sensor that we gather the data that we needed. That is very much possible. So right now, I think you know that as he touched upon that the wave power. So that is the power generation to the wave. So that is already there. To that also, what we are doing is we need to detect the level of waves while the generator part is operating. So monitoring mechanism that needed. Probably through that is the basic sensors we can develop, that is and also transmit to the any centers or the location. That is very much possible. And if you have probably one challenge would be in the middle of the sea, maybe depend on the distance, the communication might not be there. But recently they have developed the technologies like rasuwu can be implemented to those sensors and enhance that one. So since I think you mentioned about the solar energy, probably right now the solar energy is being used, but the expanding, there is the little challenges. One is actually mainly you know that the tractors, we have the ply wheels. So the ply wheels get the extra energy and release when the other side is not needed. For a solar system, so we don't have that action right now, because the conversion is doing through the inverters. But the solution, I think recently I saw that the government is going to have a large battery bank. Once it's set up, that extra energy can be transferred and get back to India as needed. Probably as undergraduates, you may develop a little bit small, you know, that the smart adapters and smart charging system, even within the house and the companies, you can use those kind of things are possible. improving the solar energy.
Adding one note to what you ask, yes, don't get me wrong, there are many satellites images which are free. Particularly, I think you have requested or you have taken Landsat series. So Landsat series is completely free. So that is what you can get, but you can't get high resolution data, right? It's completely costly. So 30 meter and Sentinel-2 10 meter, yes, you can get them. But there are certain satellites which have very high capabilities of doing more capable things. So they are not free. But as Professor said, there are a lot many things you can explore, get it free, but to do a real serious remote sensing work, you have to purchase certain things, but there are ways of doing like super resolution and fusion and all. But one last thing about this speed, there is a particular satellite sensor that can measure the speed of the waves. Because, you know, these are SAR sensors, it sends radio pulses. So when the radio pulses hits the surface of the sea, it becomes a Bragg scattering. So there is a pulse sent back to the sensor. So by that way, we can understand which way the wave is moving and with what speed, because the orbit at that time, at that particular acquisition, the orbit is specifically positioned over the Earth, and we know exactly where the satellite coordinate is. So that is also there.
Okay, so we are coming to a kind of a time limitation within this particular panel discussion. It's a wonderful panel discussion, and I would like to thank you all for your participation and putting up your thoughts forward and educating the audience. And also, as final thoughts, what we can take from this particular discussion, actually, when we are using technology and the technological disruptions are to be done, and when we are doing it, we have to think about how it could be contribute to the society in a kind of in line with the Sustainable Development Goals. And so the other thing is we have to do the technological disruption as well as without destruction of the society and the environment. So those are the thoughts we can take. And so that is, let me conclude the panel discussion here by thanking all the panelists and wish you good luck.
Thank you.
So everyone, what an enriching discussion that was. The ideas exchanged here today on technology, sustainability, and the ethical responsibility will no doubt continue to echo beyond the walls of this venue. So before we conclude this session, we would like to take a moment to express our sincere gratitude to each one of our distinguished panelists for their time, their insight, and their contribution to the conversation. So, Professor S. Vasandapriyan, your perspective on the intersection of computing and sustainable systems brought a depth to this discussion. Thank you, sir. So, Professor Roshan J. Ragal, your insights into computer engineering and the possibilities it opens for a smarter, more responsible world were both inspiring and thought-provoking. Thank you, sir. Professor Pradeep Abeygunawardena, your experience in leading one of Sri Lanka's foremost computing faculties gave this panel a perspective that connected academia directly to industry impact. Thank you, sir. And Dr. D.R. Velikanna, your contribution brought an important dimension to the conversation, reminding us that sustainability is not only a digital challenge, but a spatial and environmental one as well. Thank you so much, sir. And finally, to our moderator, Dr. Lord Chanda Ranatunga, your ability to guide this conversation with precision, balance, and grace kept this discussion both structured and live. So this session would not have been what it was without your steady hand at the helm. Thank you so much, sir. So we are now inviting the conference chair, Professor K.W.S.N. Kumari, and the Dean of the Faculty of Applied Sciences, Professor A.S. Ratnayaka, to come forward and present the tokens of appreciation to our panelists and the moderator. So, Professor S. Wasantapriyan, former Dean, Faculty of Computing, Sabaragamuwa University. Thank you so much, sir. Next, Professor Roshan J. Ragal, Professor, Department of Computer Engineering, University of Peradeniya. Thank you, sir. Next, Professor Pradeep Abegunawardena, Dean, Faculty of Computing, Sri Lanka Institute of Information Technology. Thank you, sir. And Dr. D.R. Valikanna, Senior Lecturer, Faculty of Geomatics, Sabaragamuwa University. Thank you, sir. Dr. Lochanda Ranatunga, Senior Lecturer, Faculty of IT, University of Moratuwa. Thank you, sir.
Thank you so much, gentlemen. So with that, the panel discussion session of IMPETUS 2026 is formally concluded. On behalf of the organizing committee, we are pleased to inform you that lunch has been arranged for all the guests, invitees, academics at the lobby of the Staff Learning Center. We warmly invite you to make your way there and enjoy the lunch. Following the lunch, the technical sessions of IMPETUS 2026 will be commenced at 2 p.m. across 4 parallel tracks. Please make your way to your respective venue by 2 o'clock. The track details are as follows. So the track 1 on computer and industrial information systems will be happening on D1 lecture hall, and the track 2 Data Science and Artificial Intelligence will be happening on Self-Access Center and D Computer Lab. Track 3, Robotics, Mechatronics and Embedded Systems will be happening on the main computer laboratory. Finally, the track 4 will be on Science and Technology will be happening here at the Technology Auditorium. Please check your registration details for your assigned tracks and proceed accordingly. We wish you a productive afternoon ahead. Thank you.